Lesson 1.2, Linear Equations in One Variable. Our objectives for this lesson are to solve linear equations, find X and Y intercepts, and create mathematical models with linear equations. When asked to solve an equation with one variable, your goal is to get that variable on one side of the equation and everything else on the other. To get the variable by itself, think about the order of operations PEMDAS, but work that backwards. Get rid of anything that's being added or subtracted first, then get rid of anything that's being multiplied or divided to that variable. Let's see some problems in action. Solve each of these equations for x. 3x minus 6 equals 0. This should just be a quick two-step process. If we're going to get rid of anything being added or subtracted, the 6 is being subtracted. We'll move it over by adding. And then 3 is being multiplied by x, or 2x, so we'll divide it. Make sure to simplify as best you can. 3 divided by 6, well, 6 divided by 3 is 2. That would be, whoa, what's going on? Hang on here. Sorry, guys. I don't know what's going on here. There we go. X equals 2 is the solution to that equation. I don't know what happened there. Sorry about that. Thanks for sticking with me. Over on the right, we have another one. 5x plus 4 is equal to 3x minus 8. In this situation, we have variables on each side of the equation. You want to get the variable on one side, so it always is the most efficient method to take the variable with the smallest coefficient and move it over to the variable with the biggest coefficient. That way, you should keep your coefficient positive. And then just move things over like we did before. 2x plus 4, I'll move 4 over by subtracting. Negative 8 minus 4 is negative 12. To get x by itself, divide both sides by 2. Negative 12 divided by 2 is negative 6. And that's the solution to that equation. Those are probably the easiest types of equations to solve. We'll have equations that are more complex, like the bottom two. 6 times x minus 1 plus 4 equals 3 times 7x plus 1 on the right-hand side. Now, in order to solve this, even though we think to use PEMDAS backwards, we do need to eliminate the parentheses and try to combine like terms, which means we'll distribute the 6 on the left-hand side and the 3 on the right-hand side. 6 times x would be 6x, minus 6 times 1 is 6, and then we have plus 4. On the right, 3 times 7 is 21 times x. 3 times 1 is 3. Combining like terms, we get 6x minus 2 on the left-hand side, 21x plus 3 on the right. If we have two x's, one on each side, I'm going to move the smaller coefficient over to the bigger one. We can also move the constant over, and then it just saves you an extra step. The x's cancel out on the left. Negative 2 minus 3 is negative 5. On the right, 21x minus 6x is 15x, and the 3's cancel. Now be careful on this. I have a lot of kids that would tell me this equals negative 3. If you actually get x by itself, you're going to divide by 15. And 3 is going to be in part of the answer, but it isn't negative 3, it's negative 1/3. Just watch that detail, and it'll save you some points at the end of the day. Our last problem has fractions, everybody's favorite. X over 3 plus 3x over 4 equals 2. Anytime you're adding fractions, we need to think about a common denominator. What can both 3 and 4 go into that we could change the fractions? That's not spelled right. Common denominator. Oh, wow. Sorry, guys. It's been a long day already, even though it is Saturday. The denominator. There we go. Poofda. All right. What do both 3 and 4 go into? The smallest denominator they have in common would be 12. So if we take 3 and multiply it by 4 on bottom, we'd have to multiply by 4 on top. And that would give us 4x over 12. Plus 3x over 4, well, we'd have to multiply the 4 by 3, so we have to multiply the 3x by 3 also. 3x times 3 is 9x over 12. On the right, we still have just 2. We have like terms on the left-hand side, and both terms have x. When we combine the numerator, we get 13x over 12 equals 2. And I'm going to make 2 a fraction, 2 over 1. That way we're dealing with fractions. If x is being multiplied by a fraction, instead of dividing by that fraction, we would multiply by the reciprocal. If you do that on the left side, make sure to do that on the right-hand side. 13's cancel, 12's cancel, and we get x by itself. On the right, if we multiply straight across, we would get 24 over 13. Make sure that if the fraction can be reduced, always reduce for full credit. In this case, that's as far as that fraction will go. When asked to find intercepts algebraically, you have different versions for x and y. To find the x-intercepts of a function, also known as a zero of the function, you're just going to set y equal to 0 and then solve for x. When asked to find a y-intercept, you'll do the same thing, but you'll set x equal to 0 and then solve for y. These answers should be written as ordered pairs. But we need to be careful how we do that. Let's try an example and see how it works. In our first example, find the x-intercept and y-intercept for each equation. I'm going to make a table, like a little chart kind of deal. To find the x-intercept, I'm going to plug in 0 for y. And now it's just like the algebra steps before. Solve for x. I'll move 1 over by subtracting, and then divide both sides by 4. Simple enough. X equals negative 1/4. Uh-oh, hang on. Lost my pen there for a second. Negative 1/4. But if we're writing it as an ordered pair, that's negative 1/4, comma, 0. Now do the same thing for the y-intercept. This should go a little bit faster, I would think. If we let x equal 0, that's 4 times 0 plus 1. So that's just 0 plus 1, which is 1. Not too bad. Again, as an ordered pair, 0, comma, 1. All right, what I want you to do is pause the video. Just press pause, try the next one. Once you think you have both the x and the y-intercept, press play, and we'll go on. Okay, how did you do? I got an x-intercept at 2, 0, and a y-intercept at 0, 3. Hopefully, you got the same thing. All right, we have one left. 7x minus 8y equals negative 14. Press pause, determine the x and y intercepts, and if you get fractions, always simplify completely. For our final equation, 7x minus 8y equals negative 14, I hope you got the same answers I did. The x-intercept is negative 2, 0, and the y-intercept simplified is 0, 7/4. Make sure to check your work over to make sure that you have work. You may not have every single step I do, but make sure you have enough steps to show that process. There will be a 1.2 quiz. Keep your notes out while you work on that. And then when you actually start your 1.2 assignment, it's always a great idea to refresh by looking at your notes first.